Hello viewers, welcome to BharatShakti.in. I am the editor Bharath Shakti. Today we have a series of interviews being started. The first one is about the global positioning system. And we are all too familiar with the GPS today. All that you have to do is take out your mobile and switch on the system, and the position of your car is available on screen. The system is an essential requirement in our daily lives. Trucks, buses, aircrafts, ships use the system. It's all based on the US backbone of satellites. And now we have an Indian system also in place, the IRNSS. However, the receivers that we use for picking up the GPS signals don't pick up the Indian signals. We have with us today an ex-army officer, Lieutenant Colonel V.S. Velan. He's an expert in navigation and mapping, and he will be the one who will take us through the basis today. Welcome, Colonel Velan. Welcome to BharatShakti.in.
Thank you, sir.
Right. Colonel Velan, I'll go ahead with the very first question that I have in mind, and that is, what is this global navigation satellite system, and what are the constellations available today globally?
So global navigation satellite system is a technical term for what we call as GPS everywhere, sir. It's like Xerox and photocopying. Photocopying is a technical term, but we have been using Xerox. It's a constellation of satellites, a group of satellites flown by any one of the countries. Like America has put one system called GPS and it's become more popular. Russia has got a GLONASS system. China has got Baidu system. And two more systems are coming up. That's of European Union, which is called Galileo, and of Japan, which is called QZSS. Our system, IRNSS, has been there from June 2019, fully functional, accepted by international community, and is ready for use. So this is global navigation satellite system. And along with these things, we also have certain satellite-based augmentation system, which is being used by the civil aviation people. We have WAS of America. We have IGNAS of Europe. In India, we have Gagan also. Then we have Japanese MSAS with us. So this is a full satellite constellation that help us to navigate ourselves on the globe.
Okay, Colonel Velan, let's take this a little more forward. Give us the importance of this global navigation satellite system, and what all can be monitored by it. Which are the agencies which in the bargain will be able to utilize the system?
So this using these technologies, global navigation satellite system technology, governments around the world have reduced their losses by 50%, increased efficiency by 30%, overall leading to doubling their output with the same set of resources in their control. Each government or each country has got its own system, is suiting its own requirement. For example, like GPS of America, GLONASS of Russia, it suits their requirement. Similarly, for India, we have our own system called IRNSS, and we have Gagan with us. With putting these two together, we can call in a generic term called NavIC, that is navigation with Indian constellation also, we can tell them. This can be used in every part of our national effort. For example, from the defenses, we can, the army can use it, the Navy can use it, the Air Force can use it. They are using these things already, but they're using the American constellation called GPS with them. We need to use our own system, which is created for India, which is more optimized or technically more suitable for our region because perceived for our purpose and our needs. So that's what we are, sir. In the civilian side, we have, it can be used for all your survey requirements, very precise survey, 24/7 monitoring is possible with this. When you say monitoring, then we can add all those, you can see in the backdrop, mining, public transportation, warehousing, then we can have the ambulance services, personal safety, transport corporations, logistics industry can all benefit extremely from this technology, sir.
Well, that's almost the entire facet of life, I would say, the entire facet of business activities also. But let's just go on a little further for the understanding of our viewers. They can monitoring solutions from another country. You dwelt on it a little more, but let's have a little more detail about it. A monitoring solution from another country, can it be used directly in India? Do you have to pass it through some interface? And what is the current status of NavIC and IRNSS? Are we able to field it and entirely replace GPS, perhaps within the Indian boundaries at least?
So our system is completely functional from June 2019. As I said, accepted by international communities. They've also, when we say accepted, means they test this product, they see the stability of our system, and they say, okay, it's acceptable. And ISRO has also conducted one international conference last December. There is IGC conference in India only, where all people who are dealing with this subject around the world have come here, participated, where our performance, our system has been presented. So, now, this system consists of 11 satellites of IRNSS and 3 of Gagan, which are there. In addition to that, we have 1 or 2 more satellites, what we call it as in-orbital space. 7 satellites are fully functional, 4 are yet to go up, sir. This system has got 2 frequencies in which it's transmitting. Both are what we call as L1 and S-band frequency, L5 and S-band frequency in which it's transmitting. They're also going ahead to put 1 more frequency in L1 band. Now, with these 3 bands that are available, Indian government has taken a conscious decision that all 3 bands will be open to everyone who's using this signal, and it will be made available to them. That is, the assurance will be there. Also, there will be no distinction in terms of the accuracy which is there. When we compare this to any other system, for example, the GPS of America, there's an issue with the accuracy between their 2 frequencies which they have on L1 and L2 band. L1 is not all that accurate as L2 band. L2 band is used by the armed forces. So in India, now we stand to gain. Mostly our complete defense forces can migrate to only using this constellation of satellites, have very accurate locationing for them, which can be as small as 3 meters. The system gives you 3 meters. Now compare this to about 100 meters, more than 100 meters in GPS. From 100 meters, using other technologies or certain other improvements in the electronics, which is there in the receiver, people have reduced it to about 10 meters. So from 3 meters, we can take it directly to less than a meter. This is the advantage of our system, sir. And we need to have electronics. The satellite has been put up by the government. They're being maintained there by ISRO on behalf of a government. We need to have electronics in terms of an antenna, a processor, and equipment made out of this so that you can directly use it, sir. So that's in short, sir.
Okay. Since you were talking about a little bit of comparison, can we have a more definite comparison? Is NavIC better than GPS? And what all domains will it really impact, as you see it?
So NavIC is much superior to any other type of transmission type of system today available in equatorial region, sir. See, all these systems are generally made for countries which are present on temperate regions, sir. That is above 30-degree north latitude to 65-degree north latitude, except, of course, Russia, which extends slightly more than that. Their systems have been created and optimized for this region. In this region, main difference is that the air column above their area is very stable. Whereas in the equatorial region, where India is there, here the air column is highly tumultuous. What we call it as ionospheric disturbances are there. Technically, it's called ionospheric disturbances, and they are there in a much bigger way, which cannot be templated or this cannot be compensated with simple mathematical equations. For example, to overcome this part, ISRO done study for 15 years and has come out with a very, very unique way of computing our location in this type of environment to get our locations. In addition to that, we also got a separate band, a new band called S-band. No other constellation has got this S-band transmission. This S-band is the most suitable band for a country like ours, like it's in equatorial region. In addition to that, we have that monsoonal pattern. When you get into a cloud cover, many signals get attenuated, which most of our viewers will be more familiarized with the DTH transmission that goes offline the moment we have a cloud cover. Whereas S-band transmission, which was used by our old S-while Doordarshan, giving our own satellite coverage in forward areas, it never used to go away even under snowfall or rain or thunderstorm, never used to go away. This is the beauty of S-band. So when we compare this type of transmission, perfection for use in the equatorial region and the S-band inside that, we find that our system, that's IRNSS plus Gagan, what we call today as navigation with Indian constellation, is the best suited thing for our country. Not only for our country, the area covered by this system covers from Africa to Australia and all along the Indian Ocean region. So all countries around this also can benefit out of it, sir.
Okay. Right. What I would like to know now, what are the exact services provided by NavIC, and what is important for the service, especially the three forces I'm talking about, to adopt?
So two types of services are being provided by NavIC. One is the open service, which is open to everyone. It's not encrypted. The signals and the way to take the signals and utilize within their thing is available today free on the internet. Anyone can go to ISRO site and take down this documentation and start fabricating electronics around that. That's called open service. We also have a restricted service, which will be used by our services and other restricted users of the country, like paramilitary forces, governmental agencies, by our operators across the country, who can locate themselves in a very, very fairly accurate manner in their locations. In addition to that, Gagan has got one Gagan messaging service. Now, this part is being used to transmit certain specific signals directly to the users. Today, it's being used by Incoys to send some distress signals and fishing shoal-related information to fishermen in the Indian Ocean region. The same service can be used by our services, by our armed forces, to transmit any off immediate messages across to people, sir. The delay is only 0.5 seconds. Within 0.5 seconds, the one region gets this information at immediately, almost simultaneously to everyone, sir. In addition to that, similar service is there in IRNSS also, sir. What we call IRNSS messaging service, which can be used gainfully by our armed forces, similar to the erstwhile SlideX-based transmission that we had within our signals we had. SlideX-based information is to be transmitted, very small set of information. Same way we can use this, and we can virtually have a separate system working for us if services take on this restricted service with them, have systems implemented around this.
Right, Colonel, let me get on to your company now, Elena Systems. How did you come to raise it? What were the difficulties in between? Where are you positioned now? And I would say, what is the way forward for Elena? You described a beautiful product. Which part of the whole system are you really playing with? And how do you see your product doing in the market?
So I had put up Elena as a startup, a part of technology business incubator of IIT Kharagpur. Then I had been sponsored by Ministry of Defense to go and pursue research in the same domain, sir. Because just putting up a satellite is one part of the game. To have a lot of systems built around it so that Indian public can use it, Indian Defense Forces to use it, is the most important aspect out of it. When we come to that part, we see that in GPS or the Russian part, they have done extensive study in their ground how to utilize the system for their users, sir. So similarly, we need to do a lot of research in this domain. There are about 19 to 20 study areas which this domain covers. I picked up one of the study areas. How do we convert the signal for use on a terrain? Basically for the mining region, and I was doing research there. So I put up this company there. Over a period of time, we found that we need to have someone dedicated only in this domain. That is only for the navigation domain. Like for survey people, topographical survey of India is there, and military survey group is there, which caters only for our Indian terrain, and they create things which is India specific. Similarly, we need to have someone to dedicate only in this domain. That's how Elena was born. Elena means someone who shows paths. Someone throws light onto a new path. So we have been pioneers in this domain. And today, we have end-to-end presence in this domain, sir. For example, we extend from the antennas, whenever signal leaves the satellite, from that part to the end of, till the time the users or corporates which can utilize this information as part of their ERP solution, we have the entire system with that, sir. For example, I have this full end-to-end presence presence map with you, sir. You can have a look at it. Then we have receivers, very small receivers, sir, which has got, see what our approach has been while making this receiver is that we should also make use of existing constellations or existing systems that are already present. Why should we leave out their advantage also? It's a typical Indian concept that we use what is existing and add our own thing in addition to that, sir. So today we have this a quad band receiver with us, which is only this much size, and it can receive 128 channels, sir. It can receive all signals that are present over Indian region in terms of IRNS signal, Gagan signal, which both called as NavIC. We can also take GPS, we can take Russian GLONASS signals, and if required, we can go on to Galileo signals, the Chinese Baidu signals, and the QZS signals, sir. This is also future-proof. Whenever our new signal comes up, ISRO has already shared the details of our new signal with us. It is part of their consultative process. This also can take the new L1C signal. As of today, it is available, sir. And this can be now integrated into various types of devices, and it can be put. In addition to that, we have big electronic devices around this. For example, a personal navigator we have here. This is a personal navigator, which can be used by every soldier. For in the defense side, it can be used by old people, by women, by children for their safety, sir. Beauty of our system is that we are using a concept called, it's a part of artificial intelligence. Two new concepts are developing, sir. One is edge, that's the EDG type of thing, and one is NTRIP, sir. NTRIP or TRIP is the thing, which improves on the accuracy at every stage. Since my company has got presence in every part of the domain, we have improved on each part of the system to provide one for the high precision users like defense people. We have best system possible today, which I just demonstrated to you. Another, by using a normal chip, I can improve the accuracy and give it at about 1 to 3 meters accuracy for any user. So this is my company. Going ahead, we have developed we have done research on this. We have developed the required system, and we have come out with certain set of equipment which are now finding inroads into defense one side and the public in terms of vehicle tracking system. And going ahead, we can easily integrate any type of system or solution required for any corporate or any industry at a very short time of frame, and then put it to them, sir. Another very important aspect that we give is that we can track their men, their vehicles, their equipment, or any other asset they are holding. We can track everything in one frame and present it to the decision makers in a way that they can comprehend it very better. So this is where Elena is there, sir. I think we have been...
Thank you. I think he has covered a very wide area, and the spectrum of this particular satellite-based navigation. And I'm so glad your system, as I see it, is a very small one. So it can fit into any military platform. It will not ask for too much of space as such. All the best to Elena, all the best to you. And I'm sure our viewers, you've taken us through the whole technical stuff in such a simple manner that we've all been able to understand it, perhaps. Thank you, Kal Velan. Thank you so much for having joined BharatShakti.in.
Thank you, sir. Jai Hind, sir.